Hello everyone. Today I am going to start the topic polynomials. This is a chapter 2 of 10th class CBSE syllabus. So, before going to topic, we must know what is polynomials. You must have heard the term polynomials in your previous grades. So, let us go through just the definition of polynomial. So, what is polynomials? Polynomials is nothing but it is an algebraic expression. It is an algebraic expression consisting of variables, constants, and exponents, exponents combined using operations such as addition, subtraction, and multiplication. Okay, so polynomial is nothing but it is an algebraic expression consisting of variables, constants, and exponent combining using operations such as addition, subtraction, and multiplication. Let me give you an example of polynomial. So 2x plus 3. This is one example of polynomials. Example 1. Similarly, 2x cube plus x square plus 1. This is also an example of polynomial. 2x is also a polynomial because we have here constant, we have here variable. Next, we must know what is the degree of polynomials. Next is degree of polynomials. So what is this degree of polynomial? Do you have any idea what is the degree of polynomial? Let me tell you. If p of x is a polynomial, in x, the highest degree, the highest power of x in p of x is called degree of polynomial. This is the brief description of what is the degree of polynomial. When I'll explain you with the example, so you will clearly understand what is the degree of polynomial. So if p of x is a polynomial, in x, the highest power of x in p of x is called the degree of polynomial. Let me explain you with an example. For example, 5x cube minus 4x square plus x minus root 2 is a polynomial. Okay, so here the highest degree is what? 3. Highest degree of x is 3, right? So degree, if the question appears in exam, what is the degree of polynomial of this particular polynomial, then you must write answer as 3. Why? Because in this expression the highest degree is 3. Now some expression are like 1 by x minus 1, x root x plus 2, and 1 by x square plus 2x plus 3. These are not polynomial. These are not polynomials. Such examples are not polynomials. Now, let us move to the next concept, that is linear polynomial. Linear polynomial. So, what is this linear polynomial? A polynomial of degree 1 is called as linear polynomial. I hope it is clear. A polynomial with degree 1 is called as linear polynomial. Let me give an example. That is nothing but 2x, x minus 3, or 2x minus 1, etc. Because here x means what? X raised to 1, right? So the power of x is 1. Wherever the power of the highest degree is 1, this is called as linear polynomial. Next is quadratic polynomial. Quadratic polynomial. So what is this quadratic polynomial? You know what is quadratic means, right? So quadratic polynomial nothing but a polynomial with degree 2. A polynomial with degree 2 is called as quadratic polynomial. Okay. So example, 2x square plus 3x plus 1, or 5x square plus 1. So such polynomials are called as quadratic polynomial which has the degree 1. Degree 2. Next is, third one is cubic polynomial. So when you heard about linear polynomial and quadratic polynomial, you can understand by the name cubic polynomial what it stands for. Which polynomial is called as cubic polynomial? So any polynomial which has the degree 3 is called as cubic polynomial. Degree 1 is linear polynomial, degree 2 is quadratic polynomial, and degree 3 is cubic polynomial. Example, let me give the example of this as well. 3x cube minus 1 plus 1x square, or 1x plus 2. Anything you can write in an example which has like where it is x cube. Any polynomial with x cube, y cube. Okay. So 3x cube plus 4x square plus 2x plus 1. This is also an example of cubic polynomial. 4x cube plus 2 is also a cubic polynomial. Okay. Not only x, you can take any variable. Here 4 is a constant, x is what? Variable. It is combined using some operations. Okay, addition, subtraction and multiplication. I hope it is clear. This is a basic concept you must know before going to solving the examples. Okay, so next is value of p of x. So you see here, if p of x is a polynomial in x, and if k is any real number, any real number, any real number, then the value, then the value obtained, then the value obtained by replacing, then the value obtained by replacing x by k in p of x is called what? Is called the value of p of x at x is equals to k. You must know this. Okay. So if p of x is a polynomial in x. Okay, p of x is a polynomial in x, and if k is what? Some constant value, real number. K is a real number. Then the value obtained by replacing this x by k in p of x is called was the value of p of x at x is equals to k. You'll understand this when I will solve one simple example on this. Okay, on this statement. Suppose we have a p of x. We have p of x as x cube minus 3x plus minus 4. at x is equals to -1. Okay, suppose. So what they are saying is, we want the value of p of x, right? So how we'll obtain the value of p of x? When we will replace x by -1. So here our -1 is nothing but k. Okay, k is what? -1. So x cube minus 3x minus 4, we will replace x by -1. So -1 cube minus 3 into -1 minus 4. So 1 cube minus 1 cube is -1. So minus into minus is plus. 3 into 1 is 3 minus 4. Here it will be -1 plus 3 is nothing but plus 2. 2 minus 4 is nothing but -2. So the value is -2. Suppose if x square minus 3x minus 4, we have to replace, the equation is x square minus 3x minus 4, and we have to replace x by -1, then what will get? -1 square minus 3 into -1 minus 4, that is -1 square is +1, minus 3 into -1 is -3 minus 4. So sorry, minus minus it is plus, right? So it will be 4 minus 4, so answer is 0. When we'll get the value p of k is equals to 0, we call it as 0 of polynomial. We call it as 0 of polynomial p of x. Let's understand this concept, number of zeros concept, with the example using graph. This is x dash, this is x, this is y dash, and this is y. Okay, so the graph is something like this. Okay, this is 1. Similarly, I'll draw a few more graphs for better understanding, which is given in your textbook. X dash, x, okay. So we need to find the number of zeros. How we will find the number of zeros? When a line intersect in the x-axis, when this graph, when these coordinates intersect in the x-axis, okay, at the position 0, we call it as number of zeros, okay, in any graph. So see here, in first one, the number of zeros is 1, because only one point it has intersected on the x-axis. So number of zeros is what? Number of zeros is 1, as the graph intersected x-axis at only one point. So in second example, the number of zeros is 2, because the graph has intersected at 2 points. So number of zeros in example 2 is 2. Here it is 3, right? So in third example it is 3. Fourth example it is 1, because at only one point on the x-axis the graph has intersected. Okay, so it is 1. In the fourth example it is 1. I hope it is clear. You can write the further examples, or see here also at only one point it has intersected. So the number of zeros is 1 in example 5. And here it is 1, 2, 3, 4. At 4 different points the graph has intersected. So the number of zeros is 4. Now in exercise 1, 2.1, we have the similar question which we solved previously. Okay, the question is, we have to find the number of zeros by seeing the graph. Let me write the question, then I'll explain it to you. So this is the question. Here we have to find the number of zeros in each case. So in first example 1, okay, the number of zeros. The number of zeros is 0 because the line is not touching the x-axis. Because the line is not, as the line is not touching the x-axis, the number of zeros are 0. So you have to give the comment like the graph does not cuts the graph does not, I mean explanation, does not cut the x-axis at any point. Second one is the graph is cutting the x-axis at one point. So the number of zeros is 1 because graph is cutting the x-axis at one point or intersecting at one point. Okay. Similarly, here the number of zeros are what? Here it is 1, here it is 0. Here the number of zeros are 1, 2, 3. Similar comment you have, some similar description you have to write, explanation. In fourth example, it is 2 because the graph cuts the x-axis at 2 points. Similarly, here it is 1, 2, 3, 4 because the graph cuts the x-axis at 4 points. Here it is 1, 2 and 3 because the graph cuts the x-axis at 3 points. Concept is relationship between zeros and coefficient of a polynomial. For this, we need to find the sums and products, okay, of some value a and b. There is a complete description in your textbook, but when I'll solve the example, you will understand it easily. Okay, so for now, you should understand that you need to find the value of here. For this, you need to find the sums and products. Sums in the sense there is two variables they have taken, alpha plus beta is equals to minus b by a and alpha beta is equals to c by a. So first example when we will solve, you will understand it clearly. So what is the first question? Example given at page number 30. Find the zeros of quadratic polynomial in your textbook. Example 2. So what we need to find the zeros of quadratic polynomial x square plus 7x plus 10 and verify the relationship between zeros and the coefficients. For this, first I'll write the question x square plus 7x plus 10. When we find the quadratic form, x square plus 7x, we have to split it, right? To get the sum should be 10 and sum should be 7, and when we multiply it, it should be 10. So such two values are 5 to the 10. When we add 5 plus 2, it is 7. So 5x plus 2x plus 10. You have studied this in your previous classes. So when we add two value, we should get 7, but their product should be 10. Okay, 5 to the 10, right? 5 to the 10. When we add them, it is 7. When we multiply them, it is 10. So take the common out, that is x. What is remaining inside is x plus 5. Here also take the common out. 2 is the common factor in this. So 2, when we take it out, it will be x. We have already taken it out. So x is remain here plus 2 5 is a 10. So 5. So the two values for x is x plus 5 and x plus 2 is equals to 0. It means x plus 5 is equals to 0 and x plus 2 is equals to 0. So x value will be minus 5 and minus 2. Next, so the zeros of x square plus 7x plus 10 is nothing but minus 2 and minus 5. Okay. Now sum of zeros. Now we need to find sum of zeros. In order to find the relationship between zeros and the coefficient, we need to find two things. As I told, sum of zeros and product of zeros. So sum of zeros will be minus 2 plus minus 5. We have to add them. So what will be the answer? That is minus, when we take the minus out, it will be 5 plus 2 is 7. Minus 7. Or you can even write it as minus 7 by 1. So minus coefficient of x divided by coefficient of x square. Then product of 0, minus 2 into minus 5. So it will be 5 to the 10. Right? Minus into minus is plus. So you can write it as 10 by 1. So it should be in the form of C by A. Right? It should be in the form of C by A. C is nothing but 10 and A is nothing but 1. So 10 by 1. So what is that? Constant term divided by constant term divided by coefficient of x square. So this is in the form of minus b by a, and this is in the form of c by a. We'll solve one more example which is given in your textbook. Example 3, page number 30. So the question is, find the zeros of polynomial x square minus 3 and verify the relationship between zeros and the coefficients. Okay, so you know that x square minus 3, you can write it as this is in the form of a square minus b square. The a square minus b square formula is nothing but a minus b, a plus b. So x square minus 3 can be written in this formula, that is nothing but x minus root 3 x plus root 3. So here when we equalize it to 0, so x minus root 3 is equals to 0, x plus root 3 is equals to 0. So x value becomes plus root 3 and minus root 3. So we got the x value. Let us check whether there is a relationship between zeros and coefficient. So for that we need to find sum of zeros and product of zeros. For sum of zeros, root 3 minus root 3. Sorry, root 3 plus minus root 3 is nothing but root 3 minus root 3. So this is equals to 0. Hence, minus sum of zeros should be minus b by a. Here b term is not there. Only a and c term is present. So minus b by a is nothing but 0 by 1. That is equals to 0. Next is product of root 3. Sorry, product of zeros. That is root 3 into minus root 3, that is equals to minus 3. This is nothing but minus 3 by 1. So, you know, product of zeros is nothing but c by a. What is c here? Minus 3 by 1. Right? Hence, it is constant term divided by coefficient of x square. Next is exercise 2.2. 2.2. In that, first question is find the zeros of polynomial following quadratic polynomial and verify the relationship between the zeros and the coefficients. That first question is number 1, x square minus 2x minus 8. You know, for finding the relationship between zeros and coefficient, you need to find sum of zeros and product of zeros. For that, first we need the value of zeros for this quadratic equation. So x square minus 2x minus 8, we can rewrite it as 4 into 2 is 8, 4 minus 2 is 2. So x square minus 4x plus 2x minus 8 is equals to 0. When we take the common out, x is the common here, x minus 4 is remain. When we take the common out in this, 2 is the common factor, x minus 4 is remaining inside. So it is x minus x plus 2, x minus 4 is equals to 0. So x value is nothing but minus 2 and plus 4. Now we will find the sum of zeros. That is alpha plus beta should be equals to minus b by a. Minus 2 plus 4 is equals to 4 plus 2. So you can write it as minus of minus 2, right? Minus of minus 2 by 1, that is nothing but minus b by a. Then product of zeros is nothing but c by a. Minus 2 into 4, that is equals to 8, minus 8 by 1, that is equals to minus 8, and c by a is also minus 8.